Nth roots. So, let me tell you this. If I asked you to find the square root of a number, let's say the square root of 25, explain to someone who's never ever seen this before what your thought process is here.
What number times itself to get you that number?
So I heard 5 times 5 is 25. What times itself gives you 25? So you're looking for the same number, but it's got to be multiplied twice, right? So, okay. If I told you there was, we all have all these little imaginary numbers in math, right? If there's no exponent, there's an imaginary 1. If there's no leading coefficient. If I told you that there was an imaginary 2 that sat right here small, would you understand why it's 2?
Yes, divide that number by 2.
Not divide, but
you multiply.
Multiply it 2 times, right? Does that make sense to you?
Not one bit.
Well, because 5 times
5 is 25.
Exactly.
Right. So how many times did you multiply 5 together?
Twice.
Why'd you put a number?
Twice. Because now I'm going to put another number there. Now I'm going to say,
what's the number now?
actually, let me not do that.
So how many numbers times itself? 3 times.
This time, exactly, this time I'm looking for the same number,
Wow.
but I'm looking that it multiplies 3 times because of this little 3.
Yeah.
Okay?
That makes sense.
So, good. That means what times itself 1, 2, 3 times gives me 125, and it's 5.
That's the way you're going.
Okay? That's where I'm going. So we can put any number here, whatever that number is, that tells me how many times you multiply. Okay? So I'm going to call this the nth. Okay. I'm going to call it the nth root of A. And I'm going to say, okay, what if I told you that n was 3 and A was negative 216? What would you tell me that equals now?
How many times?
It's the same thing.
216. And you know what I mean.
It's the same thing.
It is going to be, Tyler, why can it be a negative here?
Because the final answer is negative.
All right, now remember when we had square roots, we couldn't have negative under here. If it was negative under here with a square root, we had to put an I with it.
Yeah.
Why is it different with a third root here?
Because that's how yeah.
It's 3 times. What's a negative times a negative?
Positive.
Times another negative.
Negative.
So I'm looking for the same number that multiplies 3 times, that when I do, it gives me negative 216. What's the number?
8.
What is it? I'm hearing lots of different stuff.
8.
24. No, it's 8.
It's got to be the same number multiplied by itself 3 times.
9.
Okay.
16.
What is 2 times 2 times 2? 8, so that doesn't work. What is 3 times 3 times 3?
26.
27. It's 6. You're absolutely right. It's negative 6. So he had his calculator and he started doing 3 times 3 times 3. That didn't work. So then he did 4 times 4 times 4. That didn't work. Then he did 5 times 5 times 5.
Negative 6 times negative 6.
It's negative 216.
So what's the answer? Negative 6?
Negative 6.
All right.
Okay.
What we're doing?
This is part of what we're doing now.
Why is it always a part?
Yeah.
How about this one? How about this one? See if you can figure this one out.
I bet.
Wait, what?
3.
N is 4 and A is 81. It's 3. You're right. What times itself 4 times? 1, 2, 3, 4 gives you 81. And I'm right. Yes, 3. Okay?
Hey, do one where you have to do the I. Does the I matter on this?
If it's an even one, but we're not going to really get into that just yet in this section. Okay. All right. So those are nth roots. Here's what you have to understand about roots, though. When I move the laptop and get comfy, you know it's fixing to get... All right. All roots, all radicals, which are roots, can be written as exponents. What's an exponent? A little number up top, okay, a power. All roots can be written as exponents, and here's how it works. If I have, and remember, if there's not a root there, then what's the imaginary root?
1, 0, 2.
2.
Well, I didn't know that. I was just going off one.
All right, let's say I have the third root
Lots of 2.
of x squared. Because a square root, what number times itself twice? If there's not a root there, if you wanted the square root of 25, that's asking yourself what times itself twice. So if there's not one there, it's 2. All right. The cubed root of x squared, what we do is we write it as an exponent. And the way we do that, we have to write it as a fraction exponent. Okay? The number, the root is the denominator. So 3 is on the bottom and the 2 is on the top. Okay? This is called radical notation. This is called rational exponent notation. And to be successful in this whole chapter, you have to be able to fluidly move from one form to the other. Okay? Let's do another. Okay. Let's say I gave you 32 to the 2/5. How would you write that as a radical?
Alright, hey, 32 is in your little. Hey, look. Look, Miss Mickey, I'm trying to draw it out.
Oh, wow.
Holy hell.
And then put 32.
He said, holy
And
hell.
then put 2.
Sad.
Listen, I got this.
No, whenever somebody's talking, you let them finish.
What if one of the exponents is missing? For instance, if I had the third root of just x.
You don't put 1.
You're going to put 1. You're absolutely right. So it becomes x to the what?
X to the first power, X to the 1/3.
Okay. This, whenever you have a radical, understand this and this are the same, okay? You can write it under the radical with it or right outside the radical. It's the same thing, okay? Those are the same, okay? All right. So how might we use this to evaluate? Well, let me show you since you asked, Brady. I know you're such an eager beaver to learn.
For real.
Let's say I had 16 to the 3/2, and I asked you to evaluate it. Okay.
You do, hey,
Put it back in the other form. What, Brady? What's it look like in the other form? Change the form, Brady.
16 in the middle, and you draw that little box thing over it, and you put the 3 in the little thing. Yep, and then you put the 2. Yep, in the little thing.
You should know how to do this now, and it doesn't matter the order that you do it in. But do you know the square root of 16?
of course.
Of course. What is it? 4. Now raise it to the third power.
64. Now what is that number? What is that 2? What is that? What is that number with a 3 instead of a 2?
Why are you
the
raising
square root?
Yeah, what?
Why are you raising the power? What are you doing?
Look at this one because
The whole homework.
What if it's not a
perfect root?
it'll say, this one will say evaluate without a calculator. Now tell me this, before you do anything else, what does a negative exponent do to a number?
You gotta put an I.
Negative exponent. I think somebody said it.
Makes it negative.
Flip it.
What?
Flip it.
We ain't doing that no more.
We flip it. Look, this just becomes 1 over 32 to the 3/5. Now change the form.
You didn't flip it.
Yeah, then.
No, you didn't. It would be 32 and 5.
No, flip the number. Put it on the bottom of a fraction and make the exponent positive.
You added. You didn't flip.
No, I flipped the 32 down into the denominator of the fraction.
No, you didn't.
No,
Mr.
don't
G, you
flip.
just wrote a line and put 1 on the top.
That's what you do. If I had x to the negative 2, that becomes 1 over x squared.
You didn't flip nothing.
So,
Alright, so boom, look, imagine it's a 1 under that x, the first x already, now she did flip it.
Flip the whole thing, not just the exponent. So this had a 1, an imaginary 1 under it. So I just flip the fraction. The whole thing. Does that make sense? All right, we'll do another one like this in a minute. Change the form.
You gotta put the,
What's the root? Well, what's the n on the outside of the root? 5. What goes inside? What's the exponent? What's the 5th root of 32? What times itself 5 times gives you 32? It's got to be a small number, 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Yes, sorry. Times 2 is 32.
Why that one right there?
I forgot to put the 1 up because we flipped it.
So we keep doing it?
You keep it, yeah. So now it's 1 over 2 to the 3rd. What's 2 to the 3rd?
8.
Yeah.
Alright, so this is it.
No.
we gotta do more?
Mr. McGee, this is
I
enough.
love how
bud.
you've added like 10 more steps. Hold on.
Yeah, it's not on the
So
list,
take it
no,
piece by
like
piece.
it's
Yes,
5 different.
exactly.
All right.
Put me on.
And that's the 3rd step. You said it was 3rd.
There's nothing that multiplies by itself 5 times to give you 9. Do you agree? Nathan, you agree?
I agree, so you need it like that.
So what I'm going to do is I'm going to put it in my calculator.
Okay.
Okay? Now look, 9 to the 1/5. I'm going to literally do 9. I'm going to raise it up.
Yeah.
Put parentheses because it's a fraction. 1 divided by 5. 9 to the 1/5. There's my answer.
Oh, so
Why
that's
didn't you
all
just put,
you
why,
did.
why didn't you put 9 to 5th power?
what's that, Paul? We write all
Because
that down?
it's to the 1/5 power.
So do we write 1.555?
1.55 is good. 2 decimals is good. 1.55.
But I thought when you flipped it, you moved it back in the box.
Oh, okay.
Okay, so if I flip this, yes.
No, not flip it. Yeah, like that.
Yes. But
Put the 1
the
there.
problem is because there's not a number that I can say what times what times what times what times what gives me 9. There's not a whole number. So I had to use the calculator.
I know, it's going to be the same answer.
Yes, it will. And you can use the calculator. Will give you the same answer for these others as well that we did before. I'm just showing you how to use your calculator. What if, let me ask you this, what if it was the 4th root of 7 to the 3rd power? Calculator, but I'm going to change it to an exponent first. Because my calculator does exponents really easily, okay? So as an exponent, what does this look like?
7 3/4.
3/4, exactly. So you put it on your calculator and tell me what you get. 7 to 3/4.
How that doesn't make it, there's nothing that gives it 7.
There's not, yeah, there's nothing you can multiply 4 times to get 7. What did y'all get? 4.3.
Hey, to me it looks like the fraction is still in the problem.
Hey, go
It
back.
is.
Look, it says 4.3 in the answer, and that's 3/4. And then the other one.
Oh, that's just a coincidence.
Nah, it ain't.
Okay, Brady. Whatever you say. Yes or no? What you think?
Yeah.
That was just all? Is that it?
No,
So
yeah,
this
I
was-
know. Trying to